Welcome. In this video we're gonna solve another question, and in this question it tells us to find area of this triangle, and by this triangle I mean we have equilateral triangle over here, and as you guys know of this triangle or of this equilateral triangle. So this is our equilateral triangle, and by equilateral triangle we mean that the triangle that has three equal sides. So if this side is x, then this side will also be x, and if this side will also be x. So basically it has three equal sides. I know it's not the best triangle you have ever seen, but I'm not that good at drawing. So yeah, we have our equilateral triangle, and it wants from us to find the area of this equilateral triangle as a function for one of the sides. So basically what we want to get, as you guys know, all of the sides are x, so we want to get a of x. So what it does says with this as a function for one of the sides, it says get me a of x. This is what we're looking for. And so let's get our solution. So we have the a of x is what we're looking for, and in order to get this value, as you guys know, area is equivalent to half of the base multiplied by the height. And if I want to get to write the function as a of x, I need to convert this to x, so I could write it as a function of x. So in order to do that, let me redraw our triangle one more time, but this time a little bit bigger. And this is x, this is x, and this is x. And what we're trying to do is represent our h as x. So as you guys know, this is the h. By the h we mean the height. So this is our h. This is the height of our triangle, and so we will use the Pythagorean theorem to get to represent our h as x. And in order to use the Pythagorean theorem, we're gonna need this side also. So this side is, right now we don't know what it is equal to. We need to find this side. But if you look to our picture, this side starts from the middle of our base. So basically this is the half of the base, and this is the other half of the base. This is the half, and this is the half. And this side starts from this half till the end. So basically it's equivalent to half of the x. Half of the x. Yeah, so we got this value by doing this, because we know this is half of the x, half of the base. And now we will implement Pythagorean theorem, which is x squared is equivalent to h squared plus half of x squared. So what we will get is x squared equivalent to h squared plus, and since we want our h to be alone, so we could represent it as x, what we will do is send this to the other side. We end up with something like this, h, and if we do the subtraction, we end up with value like this. And since we have h squared, what we will do is gonna get the root of the each side. So in order to get the root of the square, and we have the h alone, so we end up with h minus and positive. The root of the 4 is 2. The root of 3 we don't know it, so we're gonna write it like this. And for our x squared, it's x. So over here, as you guys see, we have two values, one with the negative, one with the positive. And as you guys know, height can't be negative. The height is always positive. So we're gonna throw away this one. So h is equivalent plus. So now we can represent our h as a x. So let's do that. So let's go to write our function a of x is equivalent to half of x, and instead of h, what we're gonna write is x multiplied by the root of 3, and denominator is 2. And if we do the calculation, we're gonna end up with value like this. And as a bonus, we're gonna get the domain. What we will do, how we gonna get the domain? As you guys know, the area can't be negative or even 0, because we want the area to at least be 1, because that's how we're gonna represent the area. So in order to do that, we don't want to get a value over here as 0. And in order, when this value gets 0 is when x is equivalent to 0. So we're gonna say the domain is x such that x is bigger than 0. So yeah, thank you guys for watching this video. I hope you enjoyed this.